Polynomials SP Gubi online classes for Ncert and Cbse 9th standard classes for mathematics and science. So, in the previous session we in detail discussed regarding the value of a polynomial. So, in this session we will be discussing and solving some very simple interesting problems on zero of a polynomial. So, now at this instance we will recall the definition of what is zero of a polynomial. So, you know what is a polynomial, and it is represented by the variable inside it like p of x, p of y, p of z, p of m, p of n, something like that. So, if p of x is a polynomial, just imagine what I am telling you now. If p of x is a polynomial, so that polynomial may be a linear polynomial, maybe a quadratic polynomial, maybe a cubic polynomial, maybe biquadratic polynomial, whatever it is. Just imagine a polynomial p of x. So now, and along with that, imagine a real number k. So let k be any real number. So you have to imagine two things. One is p of x, another is any real number k. Now, in this p of x, if you substitute the value of k in the place of x, in the sense, in the place of x, that is the variable in the polynomial, if you substitute that x by k, the real number, and after substituting and simplifying the polynomial, at the end, if you get p of k is equal to 0, if you get p of k is equal to 0, then we say that k is called the zero of that polynomial because it has made the polynomial equal to 0. So for any polynomial, if you substitute a value and that value makes the polynomial equal to 0, then that value is called the zero of that polynomial. So this is very important, right? So on this particular criteria, on this particular concept, we are going to discuss very important and simple interesting problems on zero of a polynomial. So once again, I will repeat the definition. If you are not written the definition, please write this. If p of x is a polynomial and k is any real number, and if p of k is equal to 0, then k is called the zero of the polynomial. Right. So now, in this session, we have a question here. Verify whether the following are zeros of a polynomial. So at this moment, we will have to recall that for a linear polynomial, we have at most 1 0. For a quadratic polynomial, we have at most 2 zeros. For a cubic polynomial, we have at most 3 zeros. And for a biquadratic polynomial, we have at most 4 zeros. At most 4 zeros means we have 4 zeros. It may also have 3 zeros. It may also have 2 zeros. It may also have 1 0 also. Right? So here, why this happens? Because, for example, if a quadratic polynomial has 2 zeros, if I tell you, at most, I have to particularly use the word at most 2 zeros, because both the zeros, if they are real numbers, if both the zeros are real numbers, I can call them as zeros, 2 zeros of that polynomial. But out of those 2 zeros, if one of the zero is a complex number and another is a real number, therefore I mention particularly as at most 2 zeros. So it may, if one of the zero is a complex number, we are not going to consider that as a zero of that polynomial, right? So therefore we call it as at most 2 zeros, right? So if both the zeros are real numbers, okay, the quadratic polynomial has 2 zeros. If the particular quadratic polynomial has 1 0 as a complex number and 1 0 as a real number, then the number of zeros of that quadratic polynomial is 1 itself. So on this basis, linear polynomial has at most 1 0. It may also have no zeros. That's also possible. So when that one particular zero becomes a complex number, then the linear polynomial has no zeros, right? So now, verify whether the following are zeros of the polynomial which are given against them, right? So p of x is equal to 3x plus 1. Check whether x is equal to 1 by 3 is a zero of this or not. That's a very simple question. So let us check it. When you substitute the value of minus 1 by 3 in the place of x and simplify this, and if I get p of minus 1 by 3 is equal to 0, then minus 1 by 3 is called the zero of this polynomial. So we will check it. Okay, let us write down the polynomial. So p of x is equal to 3x plus 1. So put x is equal to 1 by 3, that is minus 1 by 3. So p of minus 1 by 3 is equal to 3 into, in place of x we have to substitute minus 1 by 3, okay, plus 1. So p of minus 1 by 3 is equal to 3 and 3 gets cancelled. So we are left with minus 1 plus 1. So p of minus 1 by 3 is equal to minus 1 plus 1 cancels, and that is 0. So when I substituted the value of minus 1 by 3 in this polynomial, the value of the polynomial has become equal to 0. So therefore x is equal to minus 1 by 3 is the 0 of polynomial. So since you have to write this, since p of minus 1 by 3 is equal to 0, so therefore minus 1 by 3 is a 0 of polynomial p of x. This is how we have to conclude. Giving conclusion tells us that you have the knowledge of this particular problem, right? So if you don't conclude that, that means that okay, the student has learned by some root method, he doesn't know the concept, he has not understood the theory behind this. So but when you conclude the problem in a beautiful manner, when you give a good finishing to that, we feel very happy, but because you have understood the concept. One who has understood the concept can only conclude the problem in this style, right? Let us get into the second one. So p of x is equal to 5x minus pi. So here we have to substitute 4 by 5 in this and check whether 4 by 5 is a 0 of this or not. So put x is equal to 4 by 5. So p of 4 by 5 is equal to 5 into x is 4 by 5 minus pi. 5 and 5 cancels. Okay. So p of 4 by 5 is equal to, leftover is 4 minus pi. So is this 4 minus pi equal to 0? No, because pi is 22 by 7. 4 minus 22 by 7 will give you some negative integer where it is not equal to 0 but it is less than 0. So therefore p of 4 by 5 is not equal to 0. P of 4 by 5 is not equal to 0. So therefore 4 by 5 is not a 0 of p of x. So this is how you have to conclude, right? Okay, I hope you are feeling it easy. Let us get to the third problem. Right. So p of x is equal to x square minus 1 is the given polynomial. So you have to check whether this, that is x is equal to 1 and x is equal to minus 1 are both zeros of this polynomial or not. Right, let us check out. So put x is equal to 1. So p of 1 is equal to 1 square minus 1. So p of 1 is equal to 1 minus 1. So p of 1 is equal to 0. So therefore as p of 1 has become equal to 0, so therefore 1 is a 0 of p of x. In the same manner we will check for x is equal to minus 1. So let us take the polynomial again. P of x is equal to x square minus 1. So put x is equal to minus 1. So p of minus 1 is equal to minus 1 whole square minus 1. So p of minus 1 is equal to minus 1 whole square is 1 minus 1. So it cancels. So therefore p of minus 1 is equal to 0. So minus 1 is a 0 of p of x. So here, as this is a quadratic polynomial, x square minus 1 is a quadratic polynomial. So for this quadratic polynomial we have two zeros which are both real numbers. Done? Right. When the board is complete, pause the video, write down all the things on the board and then play it. We go to the fourth problem. P of x is equal to x plus 1 into x minus 2. X is equal to minus 1 comma 2. So for this we have to check whether minus 1 and 2 are the zeros of this polynomial or not. Let us check it out. It may be asked in your examination for 2 marks. Very simple. P of x is equal to x plus 1 into x minus 2. Right. So here the polynomial is not in the standard form. So first we have to convert the polynomial into the standard form and then we will go with the procedure. Right. So P of x is equal to, what is to be done to bring it to the standard form? We have to multiply this binomial by using the distributive property of multiplication, what you have learnt in your previous classes. So x into x, x square, x into minus 2, minus 2x, plus 1 into x, plus 1x, plus 1 into minus 2, minus 2. So P of x is equal to x square, minus 2x plus 1x is minus 1x, minus 2. So now the polynomial is ready. Now it is in the standard form. Right. So now we will take the first value, x is equal to minus 1. So put x is equal to minus 1. So P of minus 1 is equal to minus 1 whole square minus 1 into minus 1 minus 2. So instead of x I have substituted minus 1. Instead of x I have substituted minus 1. So P of minus 1 is equal to minus 1 whole square is 1. Minus 1 into minus 1 is plus 1 minus 2. So P of minus 1 is equal to 1 plus 1 is 2 minus 2. It cancels. So P of minus 1 is equal to 0. So since P of minus 1 is equal to 0, therefore minus 1 is the 0 of this polynomial. So therefore minus 1 is the 0 of P of x. So let us get into the second one. So P of x is equal to, don't write this, already polynomial is ready here. You can carry the same thing. So x square minus 1x minus 2. So now put x is equal to 2 here. Put x is equal to 2. So P of 2 is equal to 2 whole square minus 1 into 2 minus 2. So P of x is equal to 2 square is 4 minus 1 into 2 is 2 minus 2. Right. So P of x is equal to 4 minus 2 is minus 4. Right. So plus 4 and minus 4 gets cancelled. So P of, sorry, I have to substitute 2 here. Right. So P of 2 is equal to, it cancels, so the value is 0. So as P of 2 is equal to 0, therefore 2 is a 0 of this polynomial. Therefore 2 is a 0 of P of x. Right, we proceed. P of x is equal to x square, where x is equal to 0. We take the sixth one. P of x is equal to Lm plus x. So Lx plus m, where x is equal to minus m by L. Third, seventh problem. P of x is equal to 2x plus 1. X is equal to 1 by 2. Right. Very simple problems. I hope you are enjoying it. So now So now we have to verify whether this 0 is x is equal to 0 is a 0 of this polynomial. So let us take the polynomial p of x is equal to x square, put x is equal to 0, so p of 0 is equal to 0 whole square, so p of 0 is equal to 0 square is 0. So here p of 0 has become equal to 0, so therefore 0 is a 0 of p of x. Don't get confused. 0 is a 0 of p of x. Very peculiar. Right. So let us get into the sixth one. So p of x is equal to lx plus m. Maybe l is some real number and m is some real number. So if you substitute minus m by l into this, we have to check whether minus m by l is a 0 of this polynomial or not. So put x is equal to minus m by l. So p of minus m by l is equal to l into, instead of x we have to substitute this minus m by l plus m. So p of minus m by l is equal to l and l cancels, so it is minus m plus m. So p of minus m by l is equal to minus m plus m cancels, it is equal to 0. So therefore, as p of minus m by l has become equal to 0, so therefore minus m by l is a 0 of this polynomial. So therefore minus m by l is a 0 of p of x. Right. So we get into the seventh problem. Same thing. So p of x is equal to 2x plus 1. We have to check whether 1 by 2 is a 0 of this polynomial or not. So put x is equal to 1 by 2. So p of 1 by 2 is equal to 2 into 1 by 2 plus 1. I have substituted 1 by 2 in place of x. So p of 1 by 2 is equal to 2 and 2 cancels. So we are left with 1 plus 1. So p of 1 by 2 is equal to 1 plus 1 is 2. So here, as p of 1 by 2 is equal to 2, it is not equal to 0. So therefore 1 by 2, since we can write this, p of 1 by 2 is not equal to 0, so therefore therefore 1 by 2 is not a 0 of p of x. Right. Okay, let us get into some more problems. So most of the students like to give this problem in a test or an examination because it's most suitable for 2 marks. So very important, please look into that. So p of x is 3x square minus 1. So you have to check whether minus 1 by root 3 is a 0 of this or 2 by root 3 is a 0 of this. So now put x is equal to minus 1 by root 3. So p of minus 1 by root 3 is equal to 3 into minus 1 by root 3 whole square minus 1. So p of minus 1 by root 3 is equal to 3 into, this square applies for minus 1 and this square applies for root 3 also. So I will show it how it happens. So minus 1 by root 3 whole square can be written as minus 1 whole square by root 3 whole square. This is how it applies for both the numerator as well as denominator. Now minus 1 whole square is minus 1 into minus 1. So minus 1 into minus 1 is plus 1, right? So 1 by root and square and root gets cancelled, that is 1 by 3. So instead of minus 1 by root 3 whole square, I can write 1 by 3. So it is 1 by 3 minus 1. So 3 and 3 gets cancelled. So P of minus 1 by root 3 is equal to 1 minus 1, that is here one time it goes, 1 into 1 is 1, minus 1 is here. So P of minus 1 by root 3 is equal to 0. So as this polynomial has been equated to 0, therefore minus 1 by root 3 is a 0 of P of x. Now let us check out this. So P of x is equal to 3x square minus 1. So put x is equal to 2 by root 3. So P of 2 by root 3 is equal to 3 into 2 by root 3 whole square minus 1. This is how we have to substitute. So P of 2 by root 3 is equal to 3 into 2 square is 4, root 3 whole square is something like this. It's cancelled, so it is 3 minus 1. So P of 2 by root 3 is equal to 3 and 3 gets cancelled, that is 4 minus 1. So P of 2 by root 3 is equal to 4 minus 1 is 3. No. So P of 2 by root 3 is not equal to 0. It is a non-zero number we have got. We should get a 0, but we have got 3. So therefore, since P of 2 by root 3 is not equal to 0, so therefore 2 by root 3 is not a 0 of P of x. I hope you are enjoying the problems, right? Find the 0 of the polynomials. Find the 0 of the polynomials in each of the following cases. In each of the following cases. First one, P of x is equal to x plus 5. P of x is equal to x minus 5. Third one, P of x is equal to 2x plus 5. Okay. Very simple. Very simple. Don't worry. Find the 0 of the polynomials in each of the following cases. So a polynomial is given to you and they are asking you to find out the 0 of it. In the previous problem, what it was there, a number was given and a polynomial was given. So they ask you to check whether this number is a 0 of this polynomial or not. So you substituted the value in that. If you get P of that number is equal to 0, then it is a 0 of the polynomial, or else it is not. But here directly they are asking you, I will give you a polynomial P of x, find the 0 of that polynomial. So 0 of the polynomial depends upon the degree of the polynomial. So if it is a linear polynomial, you are going to get 1 0. If it is a quadratic polynomial, at most you are going to get 2 zeros. If it is a cubic polynomial, at most you are going to get 3 zeros. Thing continues. But how to find the 0? Very simple. Take the polynomial what they have given. Equate that polynomial to 0. Equate that to 0. if they are given you P of x is equal to x plus 2. Take out that x plus 2, equate that to 0. Solve it, simplify that. The value of x what you will get, that is the 0 of that polynomial, that's it. Right? Okay. P of x is equal to x plus 5. Let P of x is equal to 0. Why let P of x is equal to 0? Because if you want to find the 0 of this polynomial, we have to equate P of x is equal to 0. So if P of x is 0, this entire thing becomes 0 here. So therefore, x plus 5, this one will be equal to 0. So x is equal to, plus 5 goes to the LHS, that is RHS transposes, so it becomes minus 5. So minus 5 is the 0 of this polynomial. If you want, you can check it. Put this minus 5 in the place of x. Minus 5 plus 5 cancels, it is 0. Got it? Nice. So therefore, minus 5 is 0 of P of x. Very simple. We'll do this. So P of x is equal to x minus 5. So let P of x is equal to 0. Therefore, x minus 5 is equal to 0. X is equal to minus 5 gets transposes. It is 5. Simple. When we get into this, so I have to write the statement. So 5 is 0 of P of x. Let us get into this. So P of x is equal to 2x plus 5. You please check it. It's a linear polynomial. So therefore, compulsory you are going to get 1, 0. So let P of x is equal to 0. So instead of P of x we can write 0. So therefore 2x plus 5, this is equal to 0. 2x is equal to plus 5 transposes to RHS, it becomes minus 5. X is equal to minus 5 by 2. So this is the 0. Right? So minus 5 by 2 is the 0 of P of x. Okay? Done. So these 4 problems are homework. I hope you will do this in the same method, no changes. Right. So in this session, I hope you enjoyed all the problems. Right? It was very easy. Just practice that. Get ready for a test on polynomials at the end of this week. That is coming Sunday. You are going to write a test on this. Get ready with the problems. So most of the problems will be covered to that particular time. So practice the problems. Don't waste your time. Right? Stay home, stay safe, and keep learning. Thank you.